Hi, fourth grade. Welcome back. This is our second science lesson for the upcoming week. So we have been talking about motion and learning about motion. You'll notice as we read through this booklet that there are a lot of words that we just discussed in the previous video. If you haven't watched the previous video and you haven't read that lesson, please go back and do so because a lot of those words are going to be showing up in this book as well. So we are looking at the book that says Objects in Motion. This book is by Kathy Fergang. Before we start reading, I want you to fill out your idea map that's listed on the page next to our title page. Okay? Again, it's just asking you to write ideas that you have about motion. Hopefully you should have some ideas from our previous video of what we're going to be talking about when it comes to motion. Go ahead and pause the video, take a couple minutes, write in your ideas on your concept map, and then go ahead and press play again and we'll get started on the reading. So we're going to be reading about objects in motion. We're going to start with the page that has the header, Motion. As we always read, we're going to read the header, then the paragraphs, and then the captions. And remember, captions help us figure out what is going on in the picture. I want you to read along with me so that we are practicing our reading skills. I'm going to start with the header. Use your finger to follow along so we don't lose our spot. Motion. You see objects move all around you. A car drives in a straight line and then turns. A swing moves back and forth. These changes tell about the motion of an object. Motion is a change in the position of an object. When an object moves from one place to another, its position changes. Look at the picture of the ball. When it bounces, it moves up and down. Looking at the picture at the bottom, the caption says, "A ball can bounce or roll." Now, based on this picture, it's hard to tell that it's a ball because it's showing you the motion and movement of the ball. But this is a picture of a ball and it's showing you the outline of the movement or the motion of the ball. Looking on the next page, up at the top, we're looking at the header, Relative Motion. How do you know if you are moving? You can look at things around you that do not move. A tree or a building does not move. If you ride by these things on a bike, they will seem to move, but you are the only one that is moving. If you stand still, you can tell that a passing car is moving. Relative motion is the change in position of one object compared to the position of another object. Looking at the caption at the bottom, it says, "You can tell you are in motion when you move past still objects." And in the picture, the bikers can tell they are moving because they are watching the trees on the side and they know that the trees planted in the ground do not move. Looking at the next page, we are starting with the header, Frame of Reference. Now, this was one of the vocabulary words from the previous science video. Frame of reference. How can you tell if things around you are moving? You know that some things move. You know that others do not. A water slide does not move, but the water on the slide moves. The people on the slide move too. You can see the change in position of the people and water. Objects that do not seem to move give you a frame of reference. A frame of reference is how you see something. It is kind of like a point of view. Looking at the picture, the caption reads, "The water and the girl are moving, but the slide is not." Up at the top, on the next page, we are reading, "One way to know your frame of reference is to find a reference point." A reference point is a place or an object that is used to tell if an object is in motion. For example, a girl is riding a bicycle. The objects around her that are not moving can be reference points. A reference point can tell you how fast you are moving and in what direction. Looking at the picture and the caption, the people on the swings can use objects in the distance as reference points. On the next page, we are starting with the header, Forces Affect Objects. So we're all going to start with the header. Forces affect objects. A force is any push or pull. A force can start an object moving. It can make a moving object change direction. A force can also make a moving object speed up, slow down, or stop. Some forces act only when they touch something. To throw a ball up in the air, you must give it a push. But another force will slow down the ball without touching it. That force, called gravity, will pull the ball to the ground. And we talked a little bit about that in the previous science video also. Looking at the caption to the picture, the blue marble was standing still. It moves because of the force of the yellow marble hitting it. Now, I know our packets are in black and white, so we can't see the marbles with their colors, but the darker marble is the blue marble in the center. The lighter marble behind it is the yellow marble that's going to hit the blue marble and force the blue marble to move forward. Looking at the next side, the size of a force affects the motion of an object. A large force will make an object move fast and far. A small force will make an object move slowly and not very far. Suppose you want to make a soccer ball move from one end of the field to the other. A large force is needed to move the ball a long distance. And in the picture, it tells us in the caption, the soccer player uses a force to make the ball move. When she kicks the ball, that's a force she's using to kick the ball and make it move across the field. Turning the page, we are now looking at the header that says combined forces. Combined forces. Two or more forces can act on an object at the same time. Look at the dogs in the picture. They are both pulling on the toy. The forces are the same, but in opposite directions. The forces are balanced. And if you remember in the previous video, we talked about balanced forces with the children that were playing tug of war. The toy will not move unless one dog uses a greater force than the other dog. Then the forces will be unbalanced or not even. The toy will move in the direction of the greater force. We're going to read the next paragraph, and then we're going to read the caption. Some combined forces work together. Suppose you and a friend both push a heavy box in the same direction. You might not be able to push the box by yourself, but the job is easier with your friend's help. That is because your forces are combined or together, done together. To find the total force on the box, you add the two forces together. Looking at the caption that goes with the picture. The toy does not move because the dogs are pulling with equal force. Looking at the next page, we are now looking at force and motion, and it has a picture of a bicycle. Force and motion. A force causes a moving object to change its motion. When you ride a bike, you push on the pedals. The harder you push, the faster the bike goes. The bike changes its motion when an unbalanced force acts on it. A balanced force will not affect the motion of an object. Suppose you keep pedaling the bike with the same force, then the motion of the bike will stay the same. Looking at the caption, we're going to read the top caption and then the bottom. So the top caption says, the brakes produce a force that slows or stops the bike. The bottom caption says, forces are applied to the bicycle to make it start, change speed, and stop. Looking at the next side, the side right next to it, we're going to start with friction. Friction is a force that acts when two surfaces rub together. Friction can slow or stop moving objects. The amount of friction between objects depends on the area of the rubbing surfaces. The greater the area, the more friction there is. There is also more friction if the objects press together hard. Smooth surfaces have less friction than rough surfaces. And looking at the caption at the bottom that goes with the picture, it says, the friction between the ground and the player slows down the player. So as a baseball player slides into home base, the friction slows the player down till the player comes to a stop. Looking at the next page, we are starting with the header, speed. Speed. Objects move at different speeds. Speed is the rate at which an object changes position. Speed tells how fast an object moves. A car moving at a high speed changes position faster than a car moving at a low speed. Speed is a measure of distance traveled in a given amount of time. The speed of a car might be 40 kilometers per hour. At that speed, the car would travel a distance of 40 kilometers in 1 hour. Now, in the United States, we do it miles per hour. So, to translate, instead of 40 kilometers per hour, they could be going 40 miles per hour. Looking at the caption at the bottom, it says, the speed of the rowers is the distance they travel divided by the amount of time it takes. Looking at the top of the next side, the picture with the horse and the alligator, we're going to start with the paragraph at the top and then we're going to go down through the captions. Think about two cars traveling the same distance. One travels at a speed of 40 kilometers per hour. The other travels at a speed of 50 kilometers per hour. The car moving at the faster speed will travel the distance in a shorter amount of time. Looking at the caption, animals run at different speeds. And we're going to read the caption that goes with the horse. Horses can run at speeds of about 77 kilometers per hour. That translates to 48 miles per hour. Looking at the picture of the alligator, the caption says, the top speed of an alligator is about 17 kilometers per hour, or 11 miles per hour. So as you can see, based on those pictures, a horse can run a lot faster than an alligator. Looking at the next page, we are going to be reading the header velocity. Velocity. Suppose you are in a car that is traveling 50 kilometers per hour. After 1 hour, you will have traveled 50 kilometers because it's 50 kilometers per hour. But where did the car stop? You need to know more than your speed to answer the question. You also need to know in which direction or what direction you traveled. Velocity combines the speed and the direction of an object. Some words that tell about direction are north, south, east, and west, just like when we learned about compasses. The words left, right, up, and down also tell direction. Looking at the caption that goes with the picture of the roller coaster. The roller coaster slows as it moves up to the top of the loop. The word slow tells about speed. The word up tells about direction. Looking at the next side, we're at the header that says acceleration. Acceleration. Acceleration is a change in the speed or direction of an object's motion. People often think of acceleration just as an increase in speed, but starting and slowing down are kinds of acceleration too. A change in direction is another kind of acceleration. A car on a curved road accelerates even if its speed does not change. An acceleration is any change in velocity. Looking at the picture of the car, we're going to read the caption. A race car accelerates as it travels around a racetrack. Now the last page again has our glossary with all of our words from bold that were in the lesson and the definition of what those words mean. It also has our after reading check that checks for understanding. It has 4 quick little questions, and again, all questions you can find the answers to throughout the story and using those brilliant brains of yours to figure it out. Go back, read the story again, watch the video again. You will be able to find your answers throughout the story. As always, stay safe and healthy, and I will be speaking to you later with more science information. Okay? Bye.